Whenever you realize that your application is becoming tightly coupled and the consumers of your application interfaces are at a risk if not updated in case your APIs change frequently, a pattern that can come in handy in this scenario is the commander pattern. So the commander pattern operates by separating the responsibilities of issuing commands from executing commands. So it comes in handy when usually your application or your application interfaces have some dependencies, as in there are consumers to your application. So it usually brings in the much needed flexibility and in turn helps in reducing coupling. For the sake of this example, we'll be implementing a solution for a car retailer. The retailer wants the system to give out information on the car, be able to book a test drive on that system, and facilitate the actual buying of car on that system. So let's see how we can implement the commander pattern and if it really reduces any coupling for us. We'll start with the class manager that holds our get car info function, and get car info takes in the car ID and the model. And for now, let's say does a query and returns in the car info details. Let's for now assume that it's just giving us a string which is car ID and gives us the model. Let's just see for now it's just printing the car ID and the model for the car. The next function that we wanted to implement was get test drive, and similar to this one, we'll take in the car ID and the model and we'll return a string which just says test drive booked for the car and the model. And let's just take in one more function which is the buy car function. And let's just say it just returns bots, the car ID and the model. So how do you usually access any of these methods if you want to? So usually what we go around doing is we go around with doing something like this, and there's nothing really wrong with doing an invocation like this. The only problem that we will face if we call in the car function, let's say it's a Tesla, the only problem that we'll have is that our consumers for this application interface, which is the get car info, is now tightly coupled with the interface. So for example, say that somehow this interface got changed. So let's say it got modified with get car info 1. Now your code starts breaking immediately. So every time there's an update in the interface, we'll have to update every consumer of that interface to make it work, right? So, but not with the commander pattern. So let's see how the commander pattern will solve this. So for now, let's just comment this. We have the class manager right now. So the commander pattern says that if we bring in the responsibility of executing this function to another function, so let's say it executor, or let's just say execute, and execute is a function for us which takes in the method to execute and the arguments. So it first checks in if the method to execute really exists in that object, and if so, it calls in that method using the apply function that we have. Let's just minimize the console for now. So it calls in that method with the apply function that we had, the very first pattern being this object that we need to pass to the function that is being called. So class manager dot method to execute, which will be something at runtime, for example, get car info, and we'll use the apply function to call that method and call it with some arguments. So if this works fine, what we end up getting is a different way of achieving the same option, which is rather than using class manager dot get car info directly, we will end up doing class manager dot execute and the name of the function, which is car info. Let's remove the one for now, car info, and the other arguments which could be passed in as an array, one, and let's say Tesla Model S, right? So let's just verify first if this is working. Sure. So we are getting the car info as we wanted. Just like car info, we can end up doing the buy car as well, or taking the test drive. Oops. All right. So now I can call in the get test drive method, and I've got test drive booked. And similarly for buy car, if I use buy car in place of get test drive method, I should get that, yeah, the Tesla is bought. Sure. So what this ends up doing is, so even if case any of the API methods change, your code wouldn't end up breaking if there is sufficient handling here. So for example, in the execute method, if you've handled a case that if there's no method to, if the methods to execute don't match, or in that case, you can end up calling in some default function. Let's just say for now that get car info. So all this changes can be done in the executor function. Now let's just say that our API has changed from get car info 1 to get car info 2, and our consumers are still calling get car info 1. In that case, if you want to add additional handling for every call that is made to get car info, in that is intended to go to get car info 2, what you can handle is add a default handling here, just like this one, which says that if the methods to execute do not match, so by default take get car info 2 and just call it. And this is how our code handles the situation and works really fine in that case. So even our get car info function, which is not there in the initial function list that is defined, we still end up getting a good result, which is car info, car ID, and model.